What's up everybody, it's Izzo. Welcome to the lab and welcome to Devlog 3. For today we're going to be working on CodeName AllNight, the first game I tried to develop with the intent to release. I gotta be honest, I'm excited to be working on this game again. It's been about 2 years since I've worked on it and I missed the game so much. I'm happy to be working on it with you guys too. What you're looking at right now is the frame editor for CodeName AllNight. It's really messy, but I promise when it executes this isn't what it looks like. The focus for today is going to be to fix the saving and loading system for the game. At the moment, it makes the game lag really bad at certain points. The best way to explain the problem is to just show you guys. Alright, so here we are in the game, and I'm just gonna do some looting real quick just because I like doing it. Alright, so I first noticed the problem when I was recording the first devlog for the game. Every so often the game would lag really bad, even input wouldn't be processed. So to explain kind of the problem going on, it's best to kind of describe how CodeName AllNight works in terms of like the way the world is generated and the way it's laid out. So it's a random generation game, and every time you get close enough to the screen, a new chunk is generated and it's randomized. Some chunks don't have any items like this, and then some other chunks have a lot of items. It really depends. There's two different types. One of them is just like a random type of chunk like this, and then there's another one which is like an environment chunk, which is kind of like a piece of a bigger puzzle. So every so often when these new chunks come in, a lot of items could be on the screen, and when those items are first generated in, it goes through a system that actually puts them in a list and then saves them to a file. That saving is where the lag is really taking place at. Any chunk on any given chunk can have like from anywhere from 5 to 20 items. Even like this one right here, the chunk starts probably about right here. So all of these items over here, they all just got saved. And you can also see the lag as I come in. It gets kind of hard to walk at certain points right after a new chunk is generated in. So what we're going to be doing today, the focus is going to be basically making it so all of these items, they don't save as soon as the chunk is generated. We want all of the items to save to a file at the end of a game, basically when the player exits the game, or if he gives a command to save the game itself. So that's pretty much what the focus of today is. And actually this issue is a little bit bigger, so we're going to actually be spending the next 2 videos working on this. So let's get to it. Alright, now that we've seen the problem, it's time to start fixing the logic. Welcome to the code base of CodeName AllNight. If you tuned into the first devlog, I gave a brief intro to CodeName AllNight and what you could do in the game. Really, that was a shallow intro to the game mechanics. There's so much more to CodeName AllNight, and the code base reflects it. Alright, before hopping in, just a little side note, just like I said in devlog 2, always comment your code, because right now, that's coming back to haunt me. I had to sit here for a few hours just to understand the finer pieces of the saving and loading logic. There are pieces that are commented in a good way, some that are just archaic to try to understand, and some pieces that are just uncommented. After refreshing myself, I was able to put together a plan. Big picture, the plan is to make it so the file system is only accessed at certain times, like at the end of the game, when a new segment is being generated, and if the player manually saves the game. A segment is basically a collection of chunks that you could kind of think of as a room. When the maximum amount of chunks has been reached in a room, a new room is started. The system is actually broken up into three general pieces. The first one is saving, the second one is loading, and then the third one is updating. So what we're going to do is to basically modify the saving portion of the code so that way it no longer writes to files. So we're going to start off over here. And basically we're actually running into a few issues already. One of the first issues is that I didn't think about this beforehand, like before developing the game and getting really deep into it. So the items, all of the game objects, there's no way for them to actually be grouped together. So what's going to happen is I'm going to actually have to go in and modify one of these cases for each of the objects. And it's not just these ones. There's one for each group as well. See? So a lot of objects to do. The second issue is more of a future problem, which is the system is going to need some type of communication or signal to know whether or not to write the object to a file or to destroy the object in any file that may be in existence. The reason for this is that when interacting with objects, their file status could be in any of 2 states, either waiting to be written to a file or waiting to be destroyed. The best way to handle this is to add a keyword that describes the object status to their entry into the list. Then when updating an object, instead of writing it to a file, we're going to just modify that one status keyword. So looking at the first saving thing, what you can see from the first line is that it actually adds the ID of the tree or any tree object into a tree file list. And that's what we're going to be basically modifying first. What we're going to do is we're just going to add in the status that I was just talking about, which is right. And we're going to put an underscore in front because we're going to have to tokenize this. And this is the underscore key. The underscore key is the one that I use to tokenize. Sorry, I'm having a little bit of trouble talking right now. So then after that, what we're going to do is we're actually going to take out this whole second line here. We won't need it anymore because all it's doing is just grabbing the file just to ensure it like places it in the right place. This code, this action right here actually creates a file, or it can just grab an existing file. So I'm just going to just deactivate the lines for right now. And then when we come down here, this file set flag, we're going to be taking that completely out because there's no file to be set anymore. And then the thing that's going to make this only happen once is when we look at the ID, it's going to have this ID. It's going to be the ID that was grabbed in this first one right here. So it's going to ensure that everything happens. And then down here, when it gets set to none, that's how we'll know, that's how the system will be refreshed waiting for its next object. So I'm actually going to bring this one down here, and then all of these I'm just going to delete because all of them have to do with writing to a file. Oops, deleted too many. All right. So that's essentially how modifying the saving system or the saving part of the logic is going to work. Now I just have to go and do that for every other item. Alright, so I actually just stopped real quick just to go ahead and test it out to make sure that everything's working properly. So right here you can see the list that tests the objects, or that records the objects for saving and loading. So right here we can see that for the tree it does work. It writes it instead of, it tags it with the keyword instead of writes it to a file. For the rocks though, as you can see, it does still write it to the file. So yep, I'm good to go. Okay, the next piece we'll look at is the updating file logic. For now, there are two pieces to this. The first are the actions that trigger the updating of the files. Basically, every time an object is interacted with, and for more sophisticated objects, every time a value is updated, the corresponding files are updated. Again, this adds to the lag. I didn't think about it while fixing the game the first time, but the least amount of calculations that have to be done during gameplay, the better. The second part to the update logic is actually updating the file. It works similarly to saving objects. First, the ID of the object is grabbed and given to the system so it can find or create the file. Then the file is updated, and then to finish off the rest of that, the refresh of the system happens by setting the string to none, and then the turning off of the update flag of the object. Let's talk about how we're going to be modifying the update logic. Big picture, there are three things we're going to do. First, we're going to actually have to expand the update logic. What needs to happen is we need another section for all objects to only update their entry in their respective file lists. And we'll actually keep this section of code where all files are updated. For the actual file updates, we're going to have to create a loop that will iterate through the list and toggle all flags for updating files. The final piece to this plan is modifying the actual code of the objects to not update after every value modification. Instead, we're going to only update the line in the list after the entity is supposed to be destroyed. Alright, let's get started with updating the logic by adding the facilities to update the list entries with the updates to the keyword. It's pretty similar to the updating files logic. I'm going to make some new strings for the logic, and we're going to start off by just adding those into the tree file list over here on the left side. So what I'm going to do is I'm going to add in a new string, and the string is going to be called update list ID. This ID is going to be used similarly over here. First it's going to be grabbed, and then over here we're going to actually be setting it to none when it's when all the updates have been done. And then the second thing I'm going to be adding is actually a new flag on all of the objects. So just because the tree is the object in question, that's the one I'm going to start with. This one is going to be called update list as well. And so now we can get started. So just like how we got going over here, what we're going to do is we're going to take this flag and we're going to check to make sure update list is on. And if it is, then that's pretty much what's going to start this whole entire process. So once again, we got to check to make sure this is none. The reason why we check to make sure update list is none is it stops multiple objects from being processed at once. By the time, if you were to process multiple objects at once, you might actually get some problems within that list. Some of the entries might be written incorrectly, or some of the processes might have not actually went through. So that's why we got that going. And instead of having this set current file here, all we're going to do is we're just going to set the update file to the ID. That way, you know, we got the whole thing going. So now once we got that going, we're going to go ahead and put update list down here, and same thing, we're going to be checking to make sure this is different from none. And the last part is again checking the ID against the ID that was just recorded. So now once we do all of that, this is actually it's going to be simple because all of the lists actually have an action that you can use in order to change a line. What we're going to be doing is we're going to be changing the keyword that we put in there, the right keyword, we're going to be changing that to destroy. Basically, anytime the update list is going on, that's only happening when an object is being destroyed. So for the index of the line, what we're going to do is we're going to use a different property called findStringExact, and the string that we're looking for is we're looking for the ID of the tree. So but we also have to append something onto this. For the flag, you just put -1. -1 searches the entire list. But we have to append something onto this, and the thing that we have to append is actually the right keyword, because within every list, there's actually going to be this keyword. So we want to go ahead and find that. And then the new text that we're going to be entering is pretty much the same thing, ID of the tree. And then we're going to be appending on, I actually use constants for this now. I have a new object called Game Manager, and it actually holds the codes that we're going to be using. So we're going to be just putting in the destroy code. If we look at it over here, the destroy code has the underscore and the destroy. So that's what we're going to be doing for that. And then the last thing that we're going to need to do is we're going to need to modify the object itself. We're going to be turning on a flag that I actually haven't gone over yet. It's called destroy active. The destroy active flag, it's pretty much responsible for destroying the entire object, making sure that all of the files are out the game. We'll be modifying that one. We'll be modifying this part of the code as well, because when this actually happens, we don't want the file to be destroyed anymore. And then last but not least, we're going to set this update file ID. Oh, that's supposed to be update list, by the way. We're going to change this to none, so that way the next object can be put in there, can be processed, sorry. Alright, so you guys know how we do in the lab. I don't like to put anything in, like implement a full new piece of logic without testing the first piece that I put in first. So where I'm at right now is I'm actually at the point where this is the only point in the game where you can actually be modifying the values of the tree. And as you can see the update file is there every time. Yeah, so time to fix that. All we're gonna do is we're just gonna take this out. Just gonna take that out, and then we also have to look carefully because there's two different cases for each one. One of them is for the max, is like for when it's less than 1 hit point, and one of them is for when it's equal to 1 hit point. So I'm gonna take it out of there, and then for this update file, actually what I'm going to do is I'm gonna turn on update list. That's gonna make it so basically everything's gonna be destroyed properly. Make sure that nothing else is on. Okay, and we're gonna do the same thing over here. And that should be good to go. I'm looking for the flag, the place where it's toggled, the destroy active flag that I was talking to you guys about. I'm looking for where that's toggled at. I can't find that, so I'm hoping it's handled somewhere internally. I'll figure that out in just a second and get back to you guys. Okay, so I found what I was looking for, which was where the destroy active flag was actually turned on at, and yeah, we're gonna actually be redoing a part of this. Instead of down there where the where I interact with the values, and that's where we turn on the update list at, I'm actually gonna be turning on update list here, so that way we can keep it the same, and we can have, once it's updated in the list, it still gets destroyed. So what we're going to do is we're just going to change all the destroy active flags and the checks for them to update list. Alright, so now that all of that is done, we're gonna also go back and we're gonna come back over here to where we interact with this, where we interact with the tree, and we're gonna take that one out since that's no longer needed. And now hopefully everything works correctly. We're about to test it right now. I might as well just stay on camera with you guys. So for right now, when we're testing, unfortunately I can't use a loaded game because there's actually no way for that list, like the list that gets brought in of all the objects, they're not going to have the same keywords on them. So right now the logic that we got going, it's not going to work. So I'm just going to start a new game. I hope that one inventory bug doesn't pop up again. That was kind of embarrassing. Alright, so here we go. We got all the rights. So now we're gonna, and we don't have the inventory bug, thank God, because I actually need the inventory right now. So now we're just gonna go ahead and we're just gonna try to destroy a tree. It should destroy itself, and the tree that gets destroyed should be now saying destroy. It does. Alright. That's good. We're ready to move on. Okay, now that all of the objects have the keywords that we need in order to properly save them and delete them from the list, now we're going to be looking at how to make sure that we toggle all of the objects update flags when the game is over or whenever saving is executed. All lists have to go through and save those objects to their respective files. So for this thing, we can't actually use one of the built-in loops. What we have to do is we have to basically make a custom loop. One of the reasons why is because the iterations happen so quick, it's hard to actually squeeze in all the actions before the next iteration. And then second is that the searching that we're trying to do gets really complicated because now we have to tear apart like every list entry in order to properly grab the objects by their ID. This section was actually kind of hard for me to put together in my head, so I had to work with some test cases just to play around and get the grabbing of objects correctly. What's going on right now on the screen is you're looking at kind of the test that I got going. So the first couple things that I want to point out is this update files and this update files event up here. So what's going on is we're looking and we're checking to see if this update files, which is a new flag of the list, we're checking to see if it's on. If it's on, then this right here, this group of events will be activated. If it's off, it's not. And all this group of events does is it's pretty much starting an endless loop. This endless loop is going to help us check every object against the list ID that's currently highlighted when we're starting the saving of the files. So for the testing, what I got here is I just got a little test case. So to start the test case, all I'm going to do is I'm going to press enter. When I do, it's going to set the list to the first line. It's going to select it, and then it's going to toggle the update files flag, which up here is going to start the loop. Once that loop is on, then we're going to start checking, and we're just checking one object for right now. We're checking that object's the tree's ID versus the item ID, which will be grabbed, and it's actually being tokenized up here. The way that it's being grabbed and tokenized is pretty much I have a tokenizer that splits every line, that splits a selected line inside of a list. Once it does, it gives me all of those elements. So basically I just rebuild the ID again by just taking the first and the second element of the tokenizer and then adding an underscore. That's going to give us the full ID. So once we get that, then all we're going to do is we're just going to destroy the object just to make sure it works. And just to make sure it only works one time, we're turning off the update files flag, which should stop this whole system. So now just before we start adding things in, we're just going to give it a quick test to make sure it works correctly. Okay, so here we are in the game, and all I'm going to do is I'm just going to come over here. There's a bunch of trees already generated in. That's one of the reasons why I picked the tree object. So all I'm going to do is I'm just going to press enter and see if anything happens. As we see, the last tree got destroyed, and it actually wrote down destroy as well. So we know that the system, like what we got going so far, is going to work. Now we can actually build upon that. Okay, so now that we have an idea of how to really shape the next part of the logic, let's get to implementing it. So the first thing that I want to do is introduce you guys to some modifications that I made to the file list. The first one is, instead of loop index counter being called loop index counter, I prefixed it with the actual piece of logic that it deals with, loading. And then down here I added in 3 new values. The first one is update loop index counter, the second one is update object counter, third one is files left to update. Those will all be coming in handy a little bit later. And then as for flags, in addition to the update files flag, I also added update started and files updated flag. All these flags are gonna basically be used to help with the execution and the flow of our loop to save all the objects. So the first thing that we're going to do is we're going to actually be looking at the file list itself. We're going to be taking a look at if this update files is on. This is going to actually be toggled later on in our in the logic. It's going to be toggled at the end of the game, or when saving is actually selected by the user. And then the second thing that we're going to be checking for is we're going to be checking to make sure that update started is off. The reason why we're doing this is we're going to actually be putting in some values here to help with our loop index and stuff like that, and we don't want these values to be overwritten. So the first thing I'm going to do is just come down here, add in making sure this update started flag is on. I always like to make sure those are in first, because sometimes I'll forget and then I'll just get weird errors and I'll be like, what's going on? So now for the for what we're doing inside the actions, we're going to actually just be setting all of those values that I just introduced you guys to. We're going to be setting them to the amount of lines that that are inside of the list. The reason why is the amount of lines is also the amount of entities that need to be processed and saved. So we're just going to go ahead, set all of those to that. All of these will actually be modified at different points in our logic. So yep. Okay, I'm just checking my notes real quick, making sure, seeing where we're at. Okay, the final thing that we're gonna do here is we're gonna add in setting this to the top of the list. And now with that, our actions will be started. There's one more thing that I want to add in over here, and I'm just going to actually be comparing. I don't know if this works very well. I think there's actually a value on here for the list. Yeah, there's one on here. So if the number of elements equals 0, if is greater than 0, sorry, well, we're actually gonna, that's when we're gonna actually be letting this happen. We're gonna have a whole different case for if the number of elements is 0, because if the number of elements is 0, there's nothing to process. So technically we can just skip all of this and then just go ahead, instead of toggling the update started flag, we can toggle the files updated flag, which will tell the system that this specific list, this specific part of saving is ready and you can move on. Alright guys, so we're actually going to end it here with the foundation to how to process and save objects in a given list. Just a little recap, we've already diagnosed the problem to the lag, reworked the initial object registration, added in file keywords to each list entry and gave a way to modify those keywords, planned how to process the list, and finally started to implement that logic into the game. We've done a lot today. It's pretty crazy that honestly we're only about halfway done with reworking the code. Next video we'll start where we left off here and look at the next part of things, which is processing individual list entries and their corresponding objects. Thanks everyone for joining me in the lab today and being part of the first public fix to CodeName AllNight. I'm having a lot of fun resuming development and sharing that with you guys. Leave a like if you enjoyed today's lab project, let me know what you think in the comments, and subscribe to join me in the lab for more experiments. Alright guys, have a good one, see you for the next one.